This one exercise, try do by your own. If you have any problem, single line diagram or one line diagram of the power system network. So this is the simple system. You can see it's a radial system. Since the per unit current is the same, right? Because this is a radial. So you have to find what is the actual current. Because the actual current will be different. Because of the base value. So the base current for each section will be different. And the load voltage, and also the power consumed by the load. So what is the power? Okay, choose base 100 MVA and 138 kilovolt at the line. You see from the question, they state the reference, right? So one component is taken as reference. So means that all components in the system have to refer to this selected base, which is at transmission line. So now our reference or our selected base at transmission line. So given there 100 MVA and 138 kV. So you understand the question very well. So the understanding the question is very important. So make sure you know what is the information given. You can see here from the single line diagram, there is a generator voltage 11.2 kV. So this is the actual value or all base value of the generator, 11.2 kV. However, there is no impedance or reactance for the generator. And then for transformer 1, 5 MVA. So this is the whole base power, the apparent power. So 11.2 stroke 132 kV. Okay. With the whole per unit reactance 0.1 pu. So the reactance of the transformer is in pu, all pu. So all pu. And then for transmission line, so this is the actual impedance of the transmission line, 10 plus J10 ohm. You see ohm, ohm. So in per unit, make sure you understand the unit very well. Okay. So the transmission line is given in ohm. So meaning that this is the actual impedance of the transmission line. So you have to get the base impedance so that you can find the per unit impedance of the line. Same goes for the transformer T2. So this is the whole base power, 10 MVA, 138 stroke 69. You see here 138, here 132, right? It's okay. So meaning that this is the primary, 132 here is the secondary of the transformer. So the reactance in per unit 0.1, same with the transformer 1. And then the load, Z load, only consists of the real part. You see here 30 ohm. There's no the imaginary part. So only the real part, 30 ohm. So the passive load. So meaning that to find the Z base. Before finding the Z base, we have to know what is the base voltage for each section. So for this case, we have 3 section or 3 zone. Any question regarding the question?
Doctor, for reactance XT1 tu, should we put the J in front of?
Yes. You have to consider J because the X. Because this is X, the reactance. You have to put the J. It's a complex number.
Okay, thank you, Doctor.
Even the question didn't put it, you have to understood. You have to consider J because X, reactance, is the imaginary part of the impedance, right? So in your calculation, you have to consider J. It's important.
Okay, understand, Doctor.
Okay.
Sir,
Yeah.
so our calculation will start from generator to motor lah.
No, we start from the transmission line because you are given the base at transmission line, right? So you
Okay.
can start at transmission line and then transfer the base voltage to the downstream and the upstream as well.
Oh, okay.
You cannot start from the
Easier.
generator because you see the reference at line. You are given the new base at transmission line. So meaning that to start at the transmission line
Okay,
and then
okay.
bring the base voltage depend on the transformer ratio.
Okay.
Okay.
Thank you.
Okay. Any any other questions? Before we start, okay, I hope you can understand very well the question. So you can draw the single line diagram lah, the one line diagram. So, okay. Think better, right? I full screen this one. All the information is from the single line diagram. Then we have to find the base voltage lah. Let's say VB1, VB2. So what is a new base at transmission line? Base equal to 100. A VB2 equal to VB2 138. Okay. Okay, can you find what is a VB1 and sorry VB1 and VB3? This here should be VB3, not VB2, VB3. Okay. Okay, by using the ratio of the transformer, for example, VB1 over VB2 equal to 11.2K over 132K. So can you find for VB1? VB1 equal to what? What is VB1? So did you get 11.7?
11.71.
11.71, right? Okay. All of you got the same answer,
Yes, brother. 11.71.
All right. Then VB2 is given, is our reference, and then find for VB3, So VB2 over VB3. VB3 equal to okay, 69 kV Then after finding the base voltage for each section or zone, then we can find the impedance lah, right? So we can start any component since we have known the base voltage. Let's say I start from the generator. So the generator is not given the impedance. So the next one is the transformer one lah. For example, the transformer one. So XT1 PU So to find the new per unit value for T1 lah, since you are given the old per unit, right? So what is the equation for per unit new? Old per unit values times the kV old. What is the base voltage? You can choose either primary or secondary. You can choose primary or secondary. Let's say I choose primary. So 11.2 K over old value 11.2 is the old value from the nameplate rating. The new value is VB1 is 11.71 0.71 K. So don't forget square of the base voltage times the new base power, which is fixed 100 MVA divided by old. What is the old base power? 5, right? So you should get so what you get? J 1.83
1.83.
All of you got the same answer?
Yes.
Okay. Okay, for line, Z base, what is the Z base? New base voltage square or VB2 square 138 divided by a new MVA lah. We should get
One nine 190.44.
right. Okay, then Z line PU, the actual value divided by base lah. So what you get? Better you change to polar form lah 10 plus J 10 you change to the polar form because you want to divide, right? So it easy to check your final answer.
0.07 0.074
74
45 degree.
This one the final answer not divide yet.
After divide.
After divide. So better you change first to the polar form and then divide by 190.4. So you can check if there's any mistake.
Okay,
Otherwise,
Doktor.
if you mistake error in your calculator, they will affect your answer lah, your final answer. Okay, all of you get the same answer. 0.074 angle 45 degree.
Yeah.
The line, the transition line in per unit. Okay, next. XT2 PU. Again, we have to find the new per unit value. You can choose primary or secondary. Let's say I choose secondary, 69. New also 69, right? Okay, same. In this case, old and new base voltage are similar. And then the power is 100 divided by old is 10. So should get J1 PU. Okay? Did you get for transformer 2? And finally, for the passive load, so Z base load equal to
Doktor, ada student nak masuk, Doktor.
saya auto admin.
Oh, auto admin
Auto admin. Sepatutnya tak ada masalah.
salah link lah kot dia tu.
Link yang saya bagi tadi tu. Saya dah bagi link tadi kan dekat WhatsApp group. Macam dah masuk tu? Belum lagi? Ke line dia punya line. Ni apa, Azimi pun share yang sama saya rasa ni.
Saya forward balik, Doktor.
IMM ni, apa, belakang SRE. Sama lah. Sebab saya set auto ni. Mungkin line, saya rasa mungkin network mungkin. Kena ni. So we continue. What is the base impedance at the load?
$47.61.
47.61, right? Okay. $47.61 ohm, right? Okay. Now the set load PU equal to actual value is 30. It's a real only, right? It's ohm. It's 30. There's no J there, right? Divided by 47.61. Okay. What do you get?
0.63.
0.63. Okay. Okay, now we have obtained all the component of the system in desire per unit value lah. So what's next? We have to draw the reactance diagram, right? Because we want to compute the current, voltage and power and so on lah. So draw the impedance, the reactance actually, the reactance diagram, the simplest one. Okay, this is the reactance of the T1, J1.83 for transmission line, 0. 42, and for the load, okay. Okay, now how you to find the current? We have to know the voltage, right? So from the question, you see, you are given the voltage at the generator, right? Only there is no voltage at the load, right? So
Yes.
the actual voltage at the generator, so meaning that we can find the per unit value of the generator voltage, right? So how to find the VG in per unit? So VG in per unit equal to the actual value. What's the actual value? 11 point.
0.2.
2 kV divided by, what is the base value? 11.71, right? So the actual value divided by base value. Otherwise, you cannot find the current. So you should know the voltage at the source, either at the source or at the load lah. In order to calculate the current, right? So you should get 0.96 pu. Okay, now the current equal to VG divided by Z total lah, right? So 0.96 divided by, so what is the Z total? J1.83 plus, this one you change into rectangular. So what is the rectangular value for this transmission line impedance? So what is the
2.
huh?
0.052.
0.052
2.
plus J
0.052.
0.05, same real imaginary.
Yeah. And
Okay. Because you have the summation, right? So better change from the polar to the rectangular. Easy to check. Otherwise, you are depend on your calculator. It's very difficult because you cannot see, right? Plus J1 plus 0.63, right? Okay. So you combine the real and the imaginary lah. This is the summation, right? So you can combine the real part and also the imaginary part separately lah. You combine the real and imaginary separately, so what you get? 0.96 over 0.682, 0.682, right? Plus J
2.88.
2.88. Okay, 2.88 Okay, Okay, again, we change to the polar lah, eh. Maybe you can give me the final answer. So what is the current? So in test or in your exam, better you change to the suitable form, eh. For example, this is the division, right? So you have to change this rectangular into polar. Then you can divide the magnitude, and also the angle, the 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 upper part minus the lower part, the angle. Okay. So what's the final answer? The current
0.24. 0.324.
0.324
Angle of negative 76.68.
76.68.
Yeah.
Okay. Okay. All of you get the same answer. 0.324 angle minus 76.68. Yeah? Okay, this is the current in per unit. So as I said, the current here will be similar. So the current flow through each element will be same in per unit. However, the actual current will be different because of the different base current. So what is the base current here, for example? Base current IB1, for example. Base current on section 1. IB1, base power, new. Always use new, Always use new as base divided by root 3 B base, Always use new, It's new. So you should get 100 MVA divided by root 3. So what is the new base at section 1? 11.71. So what do you get? Huh?
4.93K.
493K, Right, okay. And then IB for section 2, again 100 MVA divided by root 3. What is the base 2? Base 2 is 138, right? Okay, 138. So you should get
18.7.
0.7, Ampere, right?
0.37.
0.37 Ampere, Okay. Okay. Next. Oh, it's a bit, it's 69, right? 69, Okay, 69.
Eight 36.
Huh?
836.74.
836.74 M. Okay. So after finding the base current for each section, then you can calculate the actual value of the generator current, right? The line, the actual value of the transmission line current, and also at the load side, So you can find what is the IG PU, same right? IG PU is same, 0.324 minus 76.68. So IG in M, actual 0.324.68 times base lah, time 4.93K. So you should get okay. And then I make sure you choose the correct base, line at section 2. So you should choose the I base 2 lah, Don't use the other base, right?
.5.5.
And load.
Two seven one point one.
Yep.
271.1.
271,
Yes, point one.
Right? So this is the actual. So we have done with the current. What else?
Power.
Load voltage and the power consumed by the load, right? Okay, load voltage. Okay, right. Voltage across the load from the Ohm's law, I times the load impedance lah, So we load. So what is the I load PU? Set load. 0.2 V dot equal to so what is a V base load? V base 69, right? Okay. So you should get okay 14 kV this one in per unit, and then power consumed by the load what's the angle?
Negative 73.36.
73.36,
36.
right? Multiply by 2, right?
Yes.
Okay. So what is the base power is 100, right? Okay, 100, correct. Should get 6.6. You can ignore the imaginary, You take the actual value, right? Okay. Yeah. So this is the actual power, 6.6 megawatt, power consumed by the load. Any questions so far? So you can compare with the solution, Is it same? Is there any solution here? Okay. Okay, 6.6, 0.2.
Same the
Same, right? Okay. So the important is the concept, Get the per unit values, for each component. Then you can solve for the other parameter, For example, the current, voltage and power and so on. So any question so far? Any question?
Question, sir.
Okay.
Can you just go back to the line diagram?
The slide or
The slide there, the question.
slide? Oh, the question. Okay. Okay.
Okay, just my question is, what about if we have a branch line from point B?
Branch line?
From point B, if we have branch line from point B, do we calculate from point A to B and then to C? and then we complete our calculation with the branch line, or from A to B, and from B, let's say, to F, and then we complete with D and
Branch
C
line
and D from point
where,
A.
where is the branch line?
No, let's say we have a question. Let's say we have a question that have a branch from point B. Actually, I have the question, but I cannot share. How can I share my screen?
Yeah, you can share my screen, no problem. You can share here.
I want to.
I will stop my my presentation here. I'll stop. Oh, sorry. Where is to turn off? Stop presenting. Okay. Now you try to present your slide.
Okay, just how to present, because the first time I'm using Google Meet.
No, no problem. You just start present here. I think here you got this tab right, and down here
Yeah. So now it's okay.
present. You click your entire window or entire screen and then present. Click the button present.
I click. I already click here. Sorry.
Okay. No mind.
Now you can see or not?
Still cannot see.
Cannot.
Sorry.
There's a tab down here. You present. You click the present now,
Present now. Okay, just
uh,
1 minute.
and then
Okay. Okay. And then from this one, let's say point.
enlarge it. Can you zoom in? I cannot see cannot see very well.
Zoom.
Zoom in. Okay.
Sorry, 1 minute. Actually, this one cannot zoom.
Masih?
Okay, just okay. Just 1 minute.
Okay. So you have A, okay. Okay, let's say this is the zone 1, this is zone 2, this is zone 3, zone 4, zone 5, this is zone 6. Okay. So let's say voltage here is, let's say, I just put any number, let's say 11 stroke, like 33K. Here maybe 33 stroke 11. Here maybe 33, maybe maybe 38 stroke 10 kV. Maybe I just put randomly the value or the rating of the transformer. So
Okay,
here maybe can
Yeah,
can
no problem. Yeah.
Okay, let's say your base is 10 kV, 100 MVA. Here let's say 10 MVA. Maybe here is also 10 MVA. So maybe 10 MVA. Okay. So now you can divide the section into 6. So from the generator 1 to the primary of the generator T1. So there's a zone 1, this is zone 2. From the secondary to the primary, sorry, depends lah. It can be secondary or primary. From, let's say this is the I prefer to choose LV and HV. From the HV side of the T1 to the HV side of the T2. And then from the HV side of T2 to the HV side of the T3, and another one. Sorry, there is another one here. Zone 7. From the HV side of the T1 to the HV side of T3. And also the rest lah. From the LV side of T3 to the generator 3. From the LV side of the T2 to the generator 2, right? So you have to find the base voltage for each zone or for each section. So let's say VB1 at zone 1 lah. So what is the VB1? It's given, right? It's 10 kV. And then VB2 equal to what? VB2. So this is a VB1. So it's a VB2.
33 kV.
VB4. VB5. VB6. VB7. So VB2 over VB3. No, sorry.
VB1 over VB2?
VB1 over VB2. Because you to bring from the generator, you start from generator 1, right?
Yeah.
So you bring from the generator voltage to the other section. So VB1 over VB2 equal to 11 over 33 lah, right? Okay. So you solve for VB2 equal to 10 times 33k over 11k. Okay.
Sir, I
Yeah.
just have a question. Can we go from VB2 to VB7 directly, or we cannot?
VB2 to VB7. What do you mean? VB7 is from HB side of the T1 to the HB side of the T3. The zone, you cannot combine with this VB2 because VB2 from the HB side of the T1 to the HB side of the T2.
Okay, sorry, the VB1 to VB7.
VB1 to VB7.
Yeah, can we calculate them together or not?
Oh, you want to find the VB7?
Yeah, first, not VB2.
Okay. Same as well. You use the ratio. VB1 over
VB7.
VB7. VB7 equal to 11 over 33 K.
Yeah.
So VB7 equal to VB1 times 33 over 11K. Yes, it's similar with the VB2.
Okay, doctor, after we get VB7,
Okay.
then we have the choice to go to VB2 or VB3, right?
Yes, correct.
Okay.
It doesn't matter. You divide into the section.
Okay.
In this case, it's same, right?
Okay.
The VB2 and VB7 is same.
All right.
You divide into the section from the primary or secondary of the transformer to the another primary or secondary of the transformer.
Okay.
In this case, same. VB2 and VB7 same lah, right?
You mean the same value, right?
Yeah, the same value because the ratio of T1 is same, right?
Yes.
33, 11/33, right? Same, right?
Yes.
Okay. Any question? Others? Anyone understand? VB7, right. VB2 equal to VB7. Okay, always use the ratio of the transformer. The important is you understand. So what is the zone? Zone for each section. For each section.
Okay, doctor. Thank you.
Okay, clear? Right. Okay. Any question regarding this example? Clear? Before we continue with the others example. Okay. Okay, this is the single line diagram of the network. Select a common base of 100 MVA and 13.8 kV on the generator side. Okay. Draw the per unit impedance. I think this one is similar with the previous, but the value may be different. Okay. So you are given the all values, all base for each component. Okay, now load is given in terms of load, the passive load, is given in terms of power, in terms of power and with the power factor lah. So make sure you know how to use this the power triangle, the power triangle relationship with the power factor lagging. So means that your load is inductive load, right? Because the power factor is lagging, or theta is positive, right? Theta of the complex power is positive. So this is the inductive load. So all the component except load are given in per unit. So load is given the actual value. This is the actual value 10.45 kilovolt. And then the line impedance is 50 ohm and 70. Okay, this is the actual value lah. Okay. Okay, we can try this example. So we have one dynamic load and the one is the passive load lah. So this is our base. Our base. So again, we divide into zone. Maybe one. Okay, let's look at the parameter for each component. T1, T2, T3, T4. Here is 20. Okay. Now, what is a VB1?
13.8.
VB1 equal to 13.8. Okay, we write, clear, right? Base is our base at the generator. So this is the zone of the VB1, from the generator to the, let's say, primary of the circuit of the transformer T1 lah, or LV side, right? Okay, VB4 also same, right? Go to VB4. So this is our new base voltage. VB1 equal to VB4. We start from the generator, right? Okay. Then we continue with other part. VB. I put the old value, it's much easier to see lah. Otherwise, it's difficult. T1 is 1.8. 13.8 stroke 220. Here is 220. Yeah, okay. 33. Okay. Okay. So VB1, VB4, okay. Now VB2. So what is a VB2? The new base voltage at zone 2.
220.
220, right? I hope everyone understand how to find the new base voltage. Based on the ratio lah, use this ratio. VB1 over VB2 equal to 13.8 over 220, right? So you get VB2 equal to 220. kV and VB3 equal to 11, right? kV, VB5 VB5 equal to 132 and VB6 equal to 11. Okay, class, any question in finding a new base voltage? Okay, everyone got the same answer?
Yes.
Okay, good. No question, If you have question, please let me know, So this is the first part, the important part in finding the new base voltage, before we proceed to the other calculation, So after finding the base voltage for each section, now we can find the you see the components given here. Only load, only load the actual value, load, and others is in per unit, right? Motor reactance, others are in per unit. So means that you don't need to calculate the base lah, right? The base impedance, to save your time, depend on the question. So you can directly find the per unit value, right? So per unit value, or let's say here we can start from the generator, since our generator as a reference, right? Okay. Okay, xg equal to, don't forget J, J 18% in percentage equal to 0.18 per unit lah. This is the old per unit value, right? 18 times KVO. What is the KVO here at generator from the data is a 13.8, 13.8K over same, right? 13.8K square, base is 100, new divided by all is 90. All is 90 here. This is the all per unit value. This is all per unit value, right? Or all base value. All base value. All base value, right? From the nameplate. Did you get?
Yes.
Any question in finding the new per unit value for the generator? So from my experience, so many students also make the mistake. Here they didn't use 90. So use the old value. New is 100 divided by old. Old is 90. This is the old base power. I repeat, this is old base power. This is a new and old and new base voltage is similar. For the case of generator, transformer, and also the line impedance, except for motor and load lah, you see 10.45. So this is the old base voltage, which is different with the new one. The one is 11, you can see here. Then xt1 equal to so you can choose at primary or secondary. For T1 is a T1, right? It's a T1, T2, T3, it's a T4 lah. Okay. Let's say I choose at the LV side. Divide by 50. So you should get J 0.2. U lah. Okay, for line, yes, for line you have to find the base lah. Let's say we settle for the transformer first. XT2. Let's say I choose at the secondary. T2 old is 11, new also 11, right? Okay, sama same. T2 is 50. So I should get J 0.2. Sorry, correct, J 0.2 per unit. XT3. We get J 0.2. Let's say I choose 11 as well. So you get J 0.2. Okay. So any question in finding the reactance for the generator and all transformer before we continue with the line, So Z base, line 1 equal to Z base at line 1 okay, to 20. So you get
484. 48.
0.4, okay.
Yeah.
So 50, don't forget J, X, not Z lah, Z, X, sorry. X, right, okay. J50, you consider J since the X, divide by 484. What do you get? .103, right? And then Z, Z base for line 2, Line 2 is the base voltage there, BB5, BB5 is 132. Always use a new base power, Base power doesn't change. Okay?
Okay.
J70, so don't forget J. Okay, 0.4, Did you get 0.4?
Yes.
Okay. Okay, we have done with the line, generator and transformer. Then the final part, load, right? The dynamic load and the passive load. You can see from the data here, the load is given in terms of power, in terms of power. Okay, before that we continue with the motor lah. Motor is given in per unit, or per unit. So motor SM equal to G 0.2, 20% in all per unit equal to 0.2. What is the kV all for motor? It's given here, right? 10.45. 10.45K divided by new. What is a new base? At section 3, VB3 or VB6, 11, right? Okay. Okay. square 100. All motor rating 80, right? So you get
0.23.
okay 0.23 EU lah. Okay. And final one is the load lah. Okay. So you are given here as load equal to equal to 57. So what is the angle of the load? You remember the power triangle? So this is P, Q, this is the S, this is the theta, right? So cos theta equal to 0.8. So theta equal to what? Where's theta?
36.7.
Theta equal to 37,
6.7.
right? Okay. So the
Yes.
angle here should be 36.7 lah.
87, sir.
87.
0.87.
7. Okay. So this is the complex power. So the load is given in terms of complex power. 57 MVA. This is the apparent power. The magnitude of the complex power is the apparent power. So the angle is 36.87. So you have S equal to VI conjugate. Or I conjugate equal to, sorry, I equal to S conjugate divided by V conjugate, right? Then you substitute for I equal to V over Z equal to S conjugate over V conjugate, right? Therefore, we want to find the impedance, right? Load impedance, the actual load impedance. Then we can find the per unit. After finding the actual, we can find the per unit value, right? So the load Z equal to V times V conjugate over S conjugate lah, right? So this is equal to V square over S conjugate. Because the conjugate times the without conjugate, so the angle will be cancelled. Will be cancelled. So you get V squared. The angle zero lah, become zero angle over S conjugate. So this is the complex impedance Z. Okay. So the substitute into this expression, you can get Z load actual equal to what is the actual voltage? It's a 10.45 kV square over conjugate 57. The angle become negative lah. What you get? Did you get the same answer?
Yeah.
Correct, 1.1,
Mega sir, mega.
Huh?
Mega.
Mega.
Mega, Mega ohm,
Mega. Okay.
No.
No, right.
I'm mistaken. Because the load is mega.
This one MVA, This one KB square. Load, the complex power is in MVA, You can see here, MVA. Then we can calculate the per unit value for the load lah, right? Z load PU equal to actual divided by base. So what is a base? Base is same with the motor, right? Since the zone for the load and motor is same, right? Okay. So load and motor with the same base voltage, so the base impedance would be same lah. What is base for the motor? We didn't calculate yet, right? Okay, we calculate the base. So what is the base? Okay, Z base motor equal to 11 kV squared over 100, right? So what is the base impedance for the motor? $1.21. So you should get 157. Did you get?
Yes.
Okay, so I think we have done all the conversion from the old unit to the new per unit value, and also from the actual value to the per unit value, for the component. And check the answer. Generator, you get 0.23, so okay. And then for line, where's the line? Okay, 0.1, 0.4, okay. Okay, load, okay. 1 point, okay, you can change into polar and compare the answer, find the answer. Okay, and this is the reactance diagram lah. Okay.
Okay.
So you can draw the reactance diagram. Remember, in reactance diagram there must be one bus or one reference lah. There must be one reference. So you can draw like this lah. So generator, so you can draw the right turns of the generator, and then go to this bus bar. This is a bus 1 or main bus bar lah. Then go to the T1 reactance. So this is the bus 2, and small bus. And then the line reactance, and then this is a bus 3, 1, 2, 3, and then go for the transformer 2 reactance, and then connected to the bus 4 lah, the main bus. Okay. 1, 6, motor, and another one's load. Okay, so this is our reference lah. Reference bus. Or not. So this is the XG. Okay, you substitute all the values in this reactance diagram. Okay, class, any question?
No, sir.
Okay, so in order to find the other parameters, for example, the current, the voltage, so use your previous knowledge lah, in circuit analysis. For example, you want to find the V1, V2, V3. So use your previous knowledge. It is nothing new. So for analyze the circuit, use circuit theory. So the main concept here is to change from the old per unit value to the new per unit value. The rest, use your previous knowledge in analyze the circuit based on the parameter given lah. Based on the parameter given. Okay. Any questions so far regarding this example? This is important. If load is not given the actual value, for example, given in terms of complex power, so you have to get the actual value and then divide by the base value lah. Okay. Any question?
Doctor, I have a question but regards another problem. Is it okay if I shared my screen?
Okay, no problem. Share.
Can you see my screen now?
Yeah.
So in this case, it shows two motors with input of voltage and power.
Okay.
And there is like a faulty there, but I don't know why it's faulty, like the F.
There's a fault current. The fault occur at that bus.
Oh, okay.
There's a fault current. The fault occur at this bus bar.
Is it okay if we solve it now?
Okay, choose a common base of 40 MVA and 11 kV on the generator 1.
Yeah.
Generator 1 or generator 2? Generator 1,
Yeah.
Generator 1, where's generator 1? Okay, this side. Okay, at the left side. If motor 1 and motor 2 have input of 15 megawatt and 10 megawatt, okay, given the power at 10 kV, 10 kV is the actual value of the voltage and operate at the unity power factor. So meaning that cos theta equal to 1 lah, or theta equal to 0, right? Unity power factor. Okay,
Yeah.
determine the impedance diagram, okay? Motor voltage in per unit, okay, and a motor current in per unit, okay. So it's a current flow through the motor. We have two motor right here.
Yeah.
So first, as usual, you have to find what is the new base voltage for each section. In this case, we have 1, 2, 3, 4, 5, 6 section. 1, 2, 3, 4, 5, 6. Okay, you can stop share now.
All right.
Okay, you have this kind of system, If not mistaken, that one is the final question, I think. I don't remember which year. The past year question, But the concept is still same. Nothing new, Okay, as usual, you start with this generator, right? So you need to find what is the base voltage here. So you start with this. You selected base. So this is G1, let's say. So T1, T2, G2, T3. Okay, so you have this another one here. So this okay, let's say this is VB1, VB2, VB3, 4, 5. Okay. Then, as usual, find the base voltage for each section based on the transformer ratio. So you start from here, from the G1, right? Since this is the given selected base. Find the base value for each section. And then after find the base voltage, then you can calculate the base impedance. The base impedance for each part of the section. And then find the per unit value lah, right? So what is the per unit value for each component? For the generator, for the transformer, and also for the motor. So in this case, motor is given in terms of P, right? P. P and power factor is given. Same as well. Also the V actual is also given, right? So from this power triangle relationship, S, P, Q, T.
Yeah.
So this one is given. This one is known. So you can find what is the S, right? And also the S complex. Right? So you can find what is the S complex equal to magnitude of the apparent power with the angle. Same as we have did before in the previous example. You can find what is the S, the complex power, for the motor. Then you can find Z lah. What is the Z M1, Z M2 in per unit. Okay.
Okay,
You can find the impedance of the motor. So you are given the actual voltage for the motor, right? From the question. What is the actual voltage?
Actual voltage for the motor is 10 kV.
10 kV, right? So you can get the VPU, right? What is the voltage in per unit? By dividing the actual with the base value.
Okay.
Did you get me?
So the input of the motor is the actual value of motor.
Yeah. Then divide by the base value, you can get the per unit value of the motor.
Oh.
So as I said, depend on the question given. So you can get the actual value, the per unit value of the motor. Then to find the current, you can use other relationship. P equal to, for example, V I cos theta. This one for one phase. So remember, for power, So P, one phase PU equal to P, three phase PU, right? In per unit, power is same. Then you can find the current from this relationship. You know the voltage, you know the power, you know power factor, you can find the current. As I said, use your previous knowledge in analyze the circuit. That one I cannot teach you based on your exercise. Based on your exercise or your experience in your previous subject. Any questions so far?
No, Doctor.
Ken? Did you get me?
Yes, Doctor.
Yeah. So this is our remaining exercise, right? Another 1 and 2. I think by this we can finish it. For calculation, okay. All right, I think we can finish on Wednesday, right? The per unit part. Okay, so far any question? Please ask question if there is any unclear. Any question, class?